How about this? All right, so here's some answers. If you're ready, there are some answers for the warm-up. It's kind of hard to see C right now, but so, well, okay. So A just said list out the critical numbers and explain why. So I listed them out. Was anybody tempted to list out endpoints in that list? Yeah. Yeah, so people tend to group those together. So critical points are simply where f prime in this case is 0 or f prime doesn't exist. When we start talking about absolute extreme, and now some of the candidates are endpoints, critical points are critical points, and they are not necessarily going to be the endpoints. So I would not want you to list out endpoints in A. B, you were able to hopefully figure out some relative maximums and relative minimums. I used the first derivative test there. I did not re-explain in B why those are critical points because I already did that in A. You don't really have to repeat yourself within any one question, even if it has multiple parts. If you did, it's fine, but you don't have to. And then C was a bit of an older question. That's from concept 9. F is concave up wherever f prime is increasing, and it looks like that's happening there from 1 to 2 and 4 to 6. So do you guys have any questions on wordings? Maybe in B you were working on your wordings and yours are a little bit different than mine. You're kind of curious what we all think about that. If your wordings are different yet still good, let's talk about that. Based on your test, I think we're getting a pretty good handle on how f and f prime and f double prime relate. But I would say it's easy still to get that stuff mixed up, right? I still have people be like, wait a minute, f double prime goes from what to what? And oh gosh, is it increasing? And they start using the word it, and they get all messed up. So you can, sometimes it's not a linear path to success. Sometimes there's some days where it feels like it's 2 steps forward and 1 step backward, or 1 forward and 2 backwards, or whatever. So anyways, we really doing okay? Nobody's asking about anything? Is our class done at 20? 20, okay. All right, good deal. So nobody is asking anything, so I'm assuming that you all are feeling like you have these mastered, or have no questions at least. All right, fair enough. So let's do this. We're going to do a little think, pair, share today. So I have given you a graph of g of x down below, and what I want you all to do is think about as many observations and connections you can make regarding the relative minimums and maximums of g, and then values of g prime and values of g double prime. So I think we probably could make some nice connections with g prime, because we've already kind of been doing that, but we have yet to make any real connections with g double prime. So if you could try to do this, think about it, and then we'll pair up. I'll give you a couple minutes here to think and write, and then afterwards we'll do the pair and share. So ready, set, go. How many of you guys have ever been to the state volleyball tournament? Just to watch? Oh, yeah. Is it not the coolest thing?
Yeah, there's like 3 students last
just such a fun event.
Yeah,
We went to the semis and the finals. I don't know.
I was forced to.
Because my sister. I'll just encourage us, like I know we have football tomorrow night, so I know you have to make a choice there. But if our team makes the the semifinals, I guess it would be on Saturday, and then of course the finals, like if you have an opportunity, you've gotta go. Right, Gavin? Isn't it cool?
I didn't go to the finals last year.
Did you go to semis? Yeah, it's so fun because there's 5 matches going on at the same time, there's noise, it's exciting, it's fun. I don't know. It's a great time.
Isn't it kind of like the stock show?
It's in the stock show arena, yeah. They put down a bunch of sport court and these like big nets to make dividing walls. They roll balls out and go. It's in the evening, I want to say like 6 p.m. or 7 p.m.
Oh my god.
I played range, Highlands Range Beach, Broomfield.
For baseball?
Yeah, they were the lowest ranked team. Yeah, they already got in. But I think Broomfield is a little bit.
No.
Yeah.
I was like, going, you know.
Yeah, the 2A level.
Trying to take it back.
It's still fun.
I coached them for 4 years.
Yeah, I love coaching. It's so fun. Once my kids get old enough to work in courses, hopefully get a chance to do it. Hey, please pair up if you haven't already. We're gonna bring ideas about what's going on. Relative schema of G related with G prime and G double prime.
When I first saw it, I thought it was
I thought it was a sine wave, so my derivative was one.
I think I made this with sine.
It is?
I think I made it with a sine graph, yeah.
Ha
I think so. It could be a cubic, I guess. I don't, honestly don't remember.
It doesn't, that's not really the point.
Okay, I kind of wanted to frame this from this perspective. I just wrote up there, when G has a relative max, what are your observations? Okay, so let's talk. When G has a relative max, G double prime is negative. So did you all find the relative max right there at roughly 1/2? X equals 1/2? Make sense? Okay. So first of all, do you agree with what Reese said, that at that relative max, G double prime is negative?
Yeah.
Okay, so let's trace that back. If G double prime is negative, that means that G prime is decreasing, and G is concave down. I heard it. Yeah, there you go. Concave down. Okay, so if what Reese said is true, then those other two things would also have to be true, right? So let's analyze. The easiest one is G concave down right around that relative max. It's pretty clear from the graph. Seems like it is. Is G prime really decreasing? This one's a little bit harder to see. Let's analyze this a little bit further. Would you guys agree with me that right there, G prime is maybe like 2? And then maybe up here, G prime would maybe be, what would you say? 1 seems reasonable. Right about here, G prime is
Zero.
0. What about here? G prime would be maybe -1, something like that. And then down here, G prime is maybe -2. So if G prime goes from 2 to 1 to 0 to -1 to -2, that's an obvious decreasing pattern, right? So I think that one's true. So let's go back to the start here. It appears that G is concave down. It appears that G prime is decreasing. It appears that G double prime is negative. And we trace that all the way back to the place where G has a relative max. That makes sense? Okay, we're going to formalize this here in a minute, but that is a really nice observation. How about the other one, when G has a relative minimum? What would you say about that? Sure. Luke.
You could say G double prime is positive and has a relative max.
G double prime is positive, and what has a relative max?
G double prime has a relative
G double prime has a relative max.
and G is a relative
Hang on.
But it's just in this case.
I don't think it would have. I don't think G double prime would have a relative max. I think that my bright green graph would be G double prime, wouldn't it?
No.
Is that, or
Wait.
G double? Is that a cosine?
Or G double prime.
Wouldn't G double prime look
What
something?
is that?
I don't know if it's cosine or sine or not.
Wouldn't it look something kind of like this, just because the lines have constant slopes? Wouldn't
No, I don't think we're going to get. I don't think we're getting any points of discontinuity here. This looks, if it really is a sine graph, or if it really is a cubic, which those to me seem the most likely, then we should not have any points of discontinuity or points of non-differentiability ever. So you're assuming that this is a sine graph, right?
Yeah.
And so the connection back to G or G prime having a relative anything is based on that assumption.
Exactly.
I don't know. I honest to God don't know. It's been at least, golly, it's probably been like 4 or 5 months since I did this one, and I don't know. So I honestly don't know. So in a generic sense, I'd say that the blue-green would follow your G prime, G double prime path. If it really is sine, then maybe you're all right, but I think that's maybe too specific. Reese, what do you think? Okay, so G prime then is decreasing, G is concave. Oh, G prime is increasing, you said?
Yeah.
Okay. Increasing, G is concave, up. We all think about that. Are those good connections? I think so. Okay. Let me show you what we've been doing, and then you'll get a chance to see about this new way of looking at it. Would you guys agree with me here that on this blue stretch, G prime is negative? And then on this red stretch, G prime is positive. And then right here where I'm going to highlight in yellow, would you agree with me that right there, G prime equals 0? Roughly right in there. So if I wanted to use the first derivative test, wouldn't I say, all right, well at x equals 1/2, G prime is 0, and then G prime switches from negative to positive, therefore we've got a relative minimum. You can see it right from the graph, can't you? So we're going to, that's all still valid. We'll still use that on a regular basis. But what we're going to look at today is using kind of this reasoning that you guys have pointed out here. We're going to point out a different way of looking at this that in some cases might be easier. Okay? So I'm trying to give you one more tool for your toolbox so that in case you run into a situation where that tool would be easier, you'll have that one to use. Make sense? These are great observations. That is going to lead us right where we want to go. So check this out. Next page. I want to present to you guys a formal look at what we call the second derivative test. And not unlike the first derivative test, where we call it that because we test out the first derivative, guess what we're going to test out here? The second derivative, right? Hopefully that makes sense. So here is the second derivative test. It's in 3 pieces, just like the first derivative test was. I'll give you some words to put in the blanks. So here we go. It says, if f prime of c equals 0 and f double prime of c is positive, then f is concave up. And if you can picture some graph that's concave up at a critical point, f would have a what? Relative minimum, right? Can you picture that concave up look? You're going to get a relative minimum there at x equals c, at that critical point. So then another way this could go is you've got another critical point at c, but this time f double prime of c is negative. Then the graph of f is blank blank.
Concave down.
Concave down. And that means that f would have a relative max. You're right.
Thank you.
When x equals c. And then finally, if you have a critical point at c, so f prime of c is 0, and f double prime of c is 0, then ... we'll say the second derivative test fails. Doesn't tell us anything. And what should we do then? Give up and cry? Hide in the corner? No, we don't do that. What could we use? We could go back and use the other tool in our toolbox, first derivative test. So let me give you an example of this. A really nice example. This is just kind of an aside. You could just watch this. If we had a function f of x equals x to the 4th, this is a classic example of where the second derivative test doesn't work. Here's what would happen. We'd find our critical points, or I should say critical point. So f prime equals 0. What's my critical point? When x equals 0. And then I would find my second derivative, which is 12x squared. If I were to plug that 0 into my second derivative, what would I get out? 0. So that would tell me the second derivative test failed us. It doesn't tell us anything. The graph of f of x equals x to the 4th, anybody know what it looks like? Close. If it had turning points, it would, but it actually only has one turning point.
Looks like a quadratic.
Fat parabola. Yeah, looks like a fat parabola. So it just kind of comes out here and flattens out for just that brief point there. So it does have a relative minimum, but the second derivative test would not be able to tell you that. Second derivative test is quite useful. This is just an example of where it's not. So, FYI. All right, let's take a look at number 1. I want to give you some direction on this one, and we can discuss as needed. So, hey, and by the way, can I point out a common error? I'll point one out along the way. Are you guys ready? Okay, so this says find all relative extrema of that cubic. And then it says using the second derivative test. So can I start you off with the common error? So here's what some people will do. They will see this phrase and they will make a major error. Let me show you, and maybe you'll see it right away. The first thing I'm going to do is not necessarily an error. They'll go f prime equals this. And then they'll do this because they use the second derivative test. And they will take the second derivative and they will set the second derivative equal to 0. They'll get x is equal to 5/3 and then proceed to do some kind of a test with that. Why is that so wrong?
Because this one f prime of x is 0.
Yes.
And you have to use a sign chart to find out.
Now that would be using the first derivative test. And we are not going to use a sign chart on this one. But go back to the first thing that you said, Reese. He said, because your relative minimums and maximums are going to come from where f prime is 0 or perhaps doesn't exist. Okay? So that's it. So by the way, if I were to do this, and maybe I did take it further, and let's say I did a sign chart, and it would be an F double prime sign chart, and I put the 5/3 here. And let's say I found out that, let's see here, this would be negative and positive, I think. Let's say I did that. What would this tell me? This would definitely tell me something. What would it tell me? Concave up interval, concave down interval, right? What else would it tell me? It would tell me something else. Say again? Inflection point where?
5/3.
Yes, wouldn't I get an inflection point because F double prime changed from negative to positive? So this would tell me a lot about inflection points, and it would tell me a lot about concavity, but it would, doing what I just did right there would tell me nothing about the relative extrema of f of x. You see why this is easy to get confused? Because you see a word and you just run with it and you don't really think, what is this telling me? I would encourage you to think about that. So here we go. Let's erase all this bad stuff, at least for this particular question. So what are my candidates for relative extrema? Like, where do they come from? When f prime is 0 or d any, right? So I've got f prime right here. I'm going to set this equal to 0. And I'm going to let you all try to solve this. I'm not going to do this for you until after you've had a chance to try it. Please put in an honest-to-God effort to solve this. So make sure you know how to do it. You need to be really good at this.
So once you get these x values, do you plug them back into f of x to get the y value?
Let me see what you got here. So you took these two and plugged in there, which is exactly the right thing to do. So these numbers here, we want them to be accurate, but the most important thing about those numbers is whether they're negative or positive.
Oh,
Because if f double prime is negative, f is,
concave down.
and we have a relative
No.
maximum. And if f double prime is positive, f is concave up, and so on and so forth.
So this would still be x equals, like x equals.
Yeah, the min and max would happen at those x values. These are not x values. I should have pointed that out. This is f double prime of 7/3.
7/3.
Nope, those are actually y values in an f double prime graph. That's what we want to see, something like that. Yeah. Except I think you have it exactly. No, you got it. Never mind. Okay, so hopefully this has been enough time. Can I point out some stuff that I see from time to time? Will you promise not to call the math FBI on me? I say this in jest because I can either laugh or cry, and I'm just going to laugh. Okay? Check this out. I've seen perfectly good math students do this. So far, I'm on shaky territory. I really haven't done anything wrong yet. Getting on really shaky territory now, right? So I'm like standing right on the edge of the cliff, and I just stepped off the cliff. And I just really stepped off the cliff, right? You cannot solve a quadratic this way. It's not called the whatever you want it to be factor property. It's called the zero factor property. So the right side has to be 0. All of this was really not so good work on my part. So the step is you need to either use the quadratic formula or factoring, okay? So 3x and x, it'd be -1 minus 7. You should get x equals 7/3, x equals 1. So that other stuff. Okay, so let me take you on this journey here. If I wanted to at this point, I just want to point out your options. If I wanted to, I could do an f prime sign chart and put the 1 here and the 7/3 there and test out those intervals and figure out, does f prime go from negative to positive or positive to negative? Y'all with me? This says, though, we're supposed to not use the first derivative test, but the second derivative test. So the second derivative test requires me to have the second derivative. So I'll find it. F double prime of x equals 6x minus 10. And here's how this is different from the first derivative test. I'm going to take my critical points, and I'm going to put them directly in for the input on f double prime. So I'm going to find f double prime of 1. And what's f double prime of 1? And we want to have an exact number like you came up with. But what's the most important aspect of that number? It's negative. That's right. So I want to point that out and say that number is negative. And then I need to also find f double prime of 7/3. And what's f double prime of 7/3?
I think it's 4.
It is, right? Yeah, it's it would be
42 thirds minus 10.
42 thirds. Yeah, so 14 minus 10 is 4. And what's the most important thing about that number? Yep, that's a positive number. So here's how I would conclude this and justify my answer. I would say something like f prime of 1 is 0 and f double prime of 1 is negative. Therefore, f has a relative what? It's got to be a relative maximum. You know, we could back it up a little bit. Here, try this. We could say f prime of 1 is 0 and f double prime of 1 is negative. Therefore, f is concave down at x equals 1. Therefore, f has a relative max. You don't really have to have the part that I'm highlighting in yellow. You really don't have to have that. But if that helps you visualize a little bit and say, okay, concave down looks like this. So therefore, a critical point would have to actually be a high point. So we've got a relative max. If you want to include that, totally fine. And then the other one would be f prime of 7/3 equals 0. And f double prime of 7/3 is positive. Therefore, f has a relative min at x equals 7/3. We're basically just taking those critical points and plugging them directly into the second derivative, determining concavity of f at the critical point, leading us directly to a conclusion of relative max or min, either way. And if you even want to sketch out a little graph and say, okay, concave up, concave down, I mean, that helps, right? Do it. It's totally fine. Can you see how I try to illustrate why this is just like potentially a better tool depending on the situation? First derivative test is just as good. Just depends on the situation. Okay. All right, would you guys all then look at number 2? This is our final example today. And this says, we good? We good? Okay. So this one says, find all relative extrema of g of x equals x e to the x. Using the second derivative test, please justify the answer. Take a few minutes, see if you can figure out some critical points, a first derivative, a second derivative. Get around to that second derivative test. Sure.
For does g prime have to equal 0, or is it just a clear?
Does g prime have to equal 0, or is it? I'm not sure what you're asking.
Because for a critical point,
From 0 or dx. Yeah. So nice job with that. Nice job with that. For equal 0.
okay, so
G prime
is x e to the x.
so even though a critical point is where there's
It's 2 e to the x.
So it's where it's remember what the word is, it's where g prime doesn't exist. So saying that e to the x must be equal 0, that's not saying that g prime doesn't exist in g to the x.
okay.
It's just saying that this equation doesn't have a solution, which it doesn't have to, right?
Yeah.
It just doesn't generate the point that we're interested in. I'm glad that you guys got stuck with it. You're like, wait a minute, this doesn't seem to work. It doesn't.
Then you're just g double prime.
Yep, then you go there to, and then you can actually make a pretty quick judgment, even without a calculator, right? It's really not too bad. So you found the first derivative, and how to solve that equation? No, you don't actually. You got two terms on the left here, right? You did the product rule. So the two terms have something in common, right? I would factor it out. See what happens after you factor it out. Okay, so this is a good first step. Okay, you never really found a critical point though, right? Your candidates are where g prime is 0, so that you set this up nicely, but then you never solved it. Right, so you're going to want to take this equation and actually figure out any values of x that are solutions for that. That's going to give you a critical point or two that you can test out to see if you have relative minimums. So 0 is not a critical point. So what you would do here is you would set each factor equal to 0. So you set this, or you're right, you set this equal to 0 and you got that. If you set e to the x equals 0, what's correct? You plug in 0 to e to the 0? Well, that doesn't equal 0, right. Okay. So this is so be careful about the just like the jumping to conclusions. People are like, all right, 0 and 1, it turns out 0. Not a critical point here. Yeah, there is no solution to that equation. Just disregard. Yeah, totally disregard. Yeah, you just don't get anything out of that. Okay, let's have a good finish to our week. Did y'all recognize the product rule? We've done so many of them. Hope you're getting really, really good at that. So g prime of x then would equal 1 d2 plus 2 d1. Remember, your candidates for relative mins and maxes are where f prime is dne or is 0. I'm not concerned about dne here because that graph will always exist, but equals 0 will help us. If you factor out an e to the x, you get this. Did you guys figure out that e to the x never equals 0? So that equation just doesn't give us anything, and that's okay. Over here on this other one, we do get x equals -1. Here's how we wrap this up. It actually finishes fast. I know you're all looking at the clock like there's only 2.5 minutes left. We'll be done quite quickly. G double prime equals, it's another product rule, so 1 d2 plus 2 d1 plus the derivative of e to the x is just e to the x. So all I have to do now is plug in my my x equals -1 into g double prime. So this would give me negative e to the -1 plus 2e to the -1, right? And then if I simplify that, don't I get just e to the -1? Or 1 over e, right? And so 1 over e is the right number, so that's good. But what's the most important thing about 1 over e?
It's positive.
It's a positive number. So I can then make a conclusion and say g prime of -1 is 0, and g double prime of -1 is positive. Therefore, g is concave what? Concave up. And are you picturing a concave up graph? Would that generate a max or a min? A minimum. That's right. So therefore, g has a relative minimum at x equals -1. Please notice at no point did I ever use the word it, or them, or they, or some other generic pronoun. I referred to each of the functions by name. Please do that. That would be very helpful. So have a wonderful rest of your day and weekend. See you all on Monday.